So next we want to add gravity in. Actually, do you want to add gravity in or do you want to add collisions in? We'll add collisions in first. We're going to create another child node. Is there anything... There is a color rect. We will create a color rect just so that we can do some basic platforms, and we're going to add a collision shape. I believe that's how we do this. And collision shape. Add a child of area 2D. Yeah. So we will add a. Where is it? Reparent to new nodes. Area 2D. And we need to give it a collision shape. And we're just going to give it a rectangle. And you can see that's the actual rectangle for it. And it should be configurable in here. Yeah. So what did we give? What did we give that color rect as a size? And layout. Transform, that's what we did. Make that a nice even 500 pixels. We'll change that collision shape to be 500. And center it on it. There we go, we have a collision shape that is now a wall. And we're going to put this on a layer. Collision, there we go. So it's on layer 1. I'm going to edit the layer names just to make them a bit more a bit easier to understand. So we're going to call that solids. I'm going to call that platforms. I'm going to call layer 3 player. We don't have any player collisions yet, but we are going to put the player on its own layer. That collision shape is now on layer 1, which is solid. And we're going to treat that as if it's always solid. Every collision that we're going to do is going to want to collide with that. We put platforms on a separate one because we want to go up through the bottom of platforms. So we'll just have the up detector, the head detector, not detect platforms. Quite simple. And then again, if we want to drop through platforms, we have it so that when we go into the drop through platform state, the down detector won't detect that. And your side detectors never detect platforms. So it's just a way of compartmentalizing it and thinking ahead of time. This is how I've done this. I've done this before. This is stuff I've done lots of times in Unity, so I'm really just porting over my existing platform engine here. So back to the main movement script. We give it a... Is it a mask? Or is it a... What did they call that in there? I'm just trying to remember the names of things. It is a mask. Be on the collision shape. 2D. See also collision mask. I can't. You're giving me a link and I can't click on it. Open documentation. There we go, that's better. Actually did it. Does it have one here? No, it does not. Godot collision layer. Ow, bright. Or retry, go away. I've done this before, I know it's possible. That thing of that. There we go. Because I can't remember if it's a tag or if it's not. You know what? Screw it. I've done this before. I'm going into my old project. And we're just going to open that up. Where is it? That's what we do. It's a uint, and we give it a hint. That's what we do. So now if we go in here, and we rebuild, go into main movement, there we go, we've got ourselves a collision mask here. 1. That will collide with solid, once we actually do the test. How are we going to do the test? We're going to do raycasting. We're going to do that in the physics process. We're going to do a private void. I'm going to test right. So we're going to move the player. We're going to test right. Test left. This is a very naive way of doing it. We will possibly modify this at some point, just to bring them all together. So, how do we do raycasting again? Yeah, that's what we do. We need the world space and the space state. And we create physics query parameters. It's a lot more involved than doing it in Unity. I'll say that for a fact. So we are going to yep, so that's from the global position. So we're going to do it from and we're going to return the result, which is a collections dictionary. A Godot collections dictionary. No, we don't want it. We want to explicitly state that. Because we might want to use the built-in dictionary at some point. Problem with this is it's got some weird ass, like, it's not a solid class. It comes back with a bunch of stuff. So what we're going to do is we're going to add it to constants. You can see here, all this stuff is in there. So we're just going to add this in here. Comment that out. Not that these will change, but it just means that we can get into LSNs for these. So we now have all of these in constants, so we'll qualify that with so what we would normally do is we would now change this and we would call this input constants. And raycast constants. So I did a quick change so that these all get updated as well automatically. And now when we want to cast a ray from vector2.0 to vector2.1 times, and what we'll also put in here now is the detection. We'll make that 16 pixels. And 16 pixels. So we'll assume this is a 32 by 32 square square dude. Square player. We're going to cast a ray from the center of it to the right by that many. And what we're going to do down here is we're going to draw a line from the horizontal side. That will be our horizontal, that will be our right ray. I'm going to make that yellow and cyan. So that'll be this is our header hint. This is showing us our detection bounds. So result dot we want the position. Actually, no, we want to see if, you know what we'll do is we'll do it this way. One of the benefits of C# is we do results equals that, and we return true if one specific thing is set. So if that's not null, oh, we need to do something else with that, don't we? We need to do something else with that. We need to cast it, don't we? So if we hit something, We want that to be singular. So we try raycast. If it collides, we do something with the result. And what we want to do is we want to set the root dot position equal to new vector 2. We've got to cast that to vector 2. Collision position equals. I think that should work. We want to keep it on the same Y position. We're not varying the Y position when it hits the side. And with test left, we have the same, but we multiply it by the minus. We're not going to test up and down just yet. We'll add that in later. Here. Hopefully this just works. It did not. Why did it not work? We've got a lot of problems in the debugger. We've got errors. Key not found. Okay, because it didn't collide it through an error. Maybe that'll work better then. How do I get rid of this? Like, this is great and all, but how do I get rid of those docs? No? Make the window floating? That doesn't seem to help me at all. But yeah, sure. Okay, it's not working, but it's not throwing us any errors anymore. It's an area, isn't it? Because I'm using areas, not physics stuff. No, still not. Why are you not drawing my shit now as well? Sprite 2D is on 0, 0, isn't it? What's not? That would be why. I moved that, not the node. Nope, still not working. But it's still... That was not what I had selected. Can you stop that, please? Also, banger of a tune. There we go. Okay. Now we need to fix this. So where are we going? Where are we going? Where are we going? We want the horizontal sides. So we're hitting it on the right, like this. Or camera's mirrored. So we're hitting it like this. And we're some way into the wall. And we want to push it back. So we want to subtract when we're on the left, and we want to add when we're on the right. No, other way about. There we go. We're now stopping that. Let's put that down. So what is the size of this icon? Where is it? Can we get there? Oh, import, that's what it is. I think that should show me the size of it. No? Let's just go to show in file manager. It's an SVG. And it doesn't tell me what size it's supposed to be. That's fine. We can just measure it up against the top here. So what is that? 128 pixels? That makes sense. When the main movement, 128, 128. We want to half that because we're going from the middle outwards. So 64, 64. There we go. Nice, neat collisions now. I'll just duplicate that wall, move that over to the other side. That's to show that that's working. And just to show you it not working, we will reverse the signs. And show you getting sucked into the wall. There we go, we're stuck in the wall. That's what happens when you do the signs the wrong way. So next thing we want to do is gravity. Well, actually no, next thing we want to do is testing down. So we'll do that. We'll bring this wall down here. And we'll just, where is it? Layout, transform, 90 degrees. We'll do the same for that and make that the roof. Bring the wall in a bit, just so that we've got a nice square for easy testing. And we'll bring the main one down to the bottom. Well, I won't put it in the center because we want to see the gravity working. So now we want to do the same with this, with test down. Difference here is that we now want to add in the collision mask. So we want that to be the solid collision mask. And we want a new collision mask called platform collision mask. And we're going to swap these around.
Oh no.
Oh, thank you for the follow. Is there a reason I'm not using the built-in body nodes? I don't know how to use them, and I generally don't trust them. I like having more control over my physics and my raycasts. In this way, I have access to positions. I can do some fun things. I can get the ground normals a lot easier. Generally speaking, built-in physics, I've learned this from Unity, is that while they are good for using your basic, building a basic game out of, if you want to do anything more complicated, it's kind of funky. You need more fine-grained control. And my other engine that I'm working on, that you would have seen at the start, Gotta Go Fast, is a Sonic the Hedgehog style momentum platformer, and you really need to use this method of doing it just so that you've got the same kind of access that you would have done if you were doing this on like the Mega Drive or the SNES. Basically, they are too complicated for their own good. I know saying it's too complicated for its own good, and I'm doing this, you know. But this kind of gives you an idea of how each section is working. And this isn't the thing. This is a lot of code reuse. We are going to tidy this up eventually. Actually, we'll definitely combine these two together. So now we are testing down. What else was it? Oh yeah. So testing down. If you have collided, we want to set your position to that. We also want to record what the ground is. We'll come into this later. But we want private node. Actually, we want node 2D because we do care about the position. And we want current ground to equal result raycast constants dot collider else if current ground is not null. So this is us transitioning from the ground state to an air state. That'll come in handy later. If you're not doing that, that's fine. What we're going to do up here is we're going to expose a non-exported property. Public is grounded. I'm just going to do that as current ground. It helps if I actually give it a type. Public bool is grounded. All it does is do that. So now we have a shortcut to that. So where's the physics one? Where's the physics? So if is not grounded, Really put in the deltas there. And this is where Godot C#. It's a little bit janky. You have to do the multiplication and then cast it to a float so that we can multiply it by a vector. I don't know why everything's in doubles, but the vectors aren't. What that does mean is that we will have to increase the walk speed, because otherwise it'll be very slow. So we go back in here, we build, animate movement, make it 100 pixels per second, the gravity the same. So gravity is a bit slow. Gravity is just constant right now. We're not increasing. We're not keeping score of the speed. So that should just work. That should just work. And it just doesn't. What happened there? Why did that move off to the side? We didn't set the platform collision mask for one thing, but that's because we need to set it for that. That's fine. We'll increase the gravity. Okay, we'll make it 300. Did that move off to the left a bit? I don't know. We do want to increase that walk speed though. Look at 200. It did seem to want to move slightly. Oh, it's debug. That's why it's not showing up. Okay, maybe I'm just imagining it. The X position isn't changing. That's fine. Always go to sanity check these things when you see something that doesn't look right. So, we have gravity in. Of a sort. We're not accelerating in any reference frame. We're going to add test up in as well. So if we hit something, we're going to do this upwards, which is negative y. We're just going to do this as the solid collision mask, because we don't care about platforms. We want to jump up through the bottom of platforms. This is also one of the reasons that I like using my own raycast as well, is that you can put in your own collision masks for the different ways of doing things. I've not yet found a tutorial that does the jumping through platforms like the same way that I do it, and this just makes a lot more sense to me. So test up. We want to add that to that. We also don't care about that. We're now going to add in acceleration. So rather than, so if not grounded, y speed plus equals gravity times delta. We will also have to increase the gravity a lot. I'm going to make these doubles now. I'm going to change that to y speed Because now we're multiplying by delta twice. We effectively, gravity needs to be higher to have a better effect. Let's see. That kind of makes sense. That's fine. What we need to do now is when you hit the ground, set the Y speed to 0 again. And when we hit a ceiling, we set the Y speed to 0. Now, one thing we need to do here, it won't make a difference now, but it will make a difference later on when we add jumping in and when we add extended jumping. If Y speed is less than 0, as in if it's in the up direction, then you set it to 0. If it's 0 or positive and you've hit your head, you don't want to set it to 0 because you're heading downwards anyway. All that will do is make you glue yourself to the ceiling. And that's not fun. You can see there's a bit of speed up there. We'll move him back up to the top there. There you go. It still does look like it's moving to the left slightly, but it might just be that it's locking to the pixels. Graphical weirdness. We can fix that when we actually look at the properties. So now what we're going to do is we're going to add jumping in. Well, actually, no, what we're going to do now is we're going to set the Y speed to minus 100 to start with. Okay, maybe minus 1000. Oh, that's X speed, you dafty. That, I mean, yeah, that it doesn't sound like it's the same issue, or maybe it is. You could hit a sign when the light was in the off state. I don't know. I haven't heard that one before, and I missed if we hit the ceiling or not. We didn't hit the ceiling. Okay, that's fine. We'll just move you closer to the ceiling. Yeah, we hit the ceiling there. Cool. We'll move you back to the center. Okay. We'll make these a little bit better numbers. Right now, with this really low gravity, it will feel a little bit floaty, so we're probably going to set that to 500. That's a bit better.